we are going to learn about our topic number 6, data type. So let's move on. Data types. So the program consists of data and its type, because whatever you are going to be stored in the form of data, and your data can be integer, float, double, character. So what we are going to learn today is that data type. So data type are responsible to allocate memory space on RAM and specify its two things. So if we are going to learn about the data types, then we will learn that they are responsible to allocate memory space on RAM, because whatever we are going to process in the C language, whatever the value we are going to give, that is going into the RAM, and RAM going to allocate some space for that particular program. So data are responsible to allocate memory space on RAM, simply we can say, because RAM is a random access memory. So it allocates an area of memory when we give advice to the compiler of the C language that I am using integer variable name. That is integer, that is the data type, and variable name is that name which represent the type integer. So the area is going to allocate into the RAM of that size. So it is specify two things. First thing is specify size of variables in byte, that what is the size of the variable in bytes, and specify types of variables. So two things is going to be specified, that is size and type. So C compiler provides mainly four types of data types, and these are as follows. So let's look at this. So data type, you are seeing here about the char data type, whose size is 1 byte, int data type, whose size is 2 byte, float data type, whose size is 4 byte, double data type, whose size is 8 byte, and void. Void means empty, that is containing 1 byte. So we overall we can say that if we are considering the data type, then we have to consider two things. We have to specify two things, that is its size and type. So whatever the data is going to be stored into the RAM, it is going in the form of allocating a memory space on the RAM, and this is how the size is going to differ in system. So if we are using 32 byte, then the size of CAD might be changed, and if we are using 64-bit system, then the size of this data type might be changed. So this is how data are arranged into the C language. We will learn about the basic and the mechanism through which the data is going to be stored into the RAM. That how area is going to be allocated for integer data type, for the float data type, for the double data type, for the void data type, and for the char data type. And of course, if the size is larger, then area will be larger. It is a fact. So here we can see that double data type has its larger size. Therefore, it allocates larger space into the RAM, and we can say char and void. Char here, you look here, that char and void is going to store 1 byte. Therefore, we can say that it is going to allocate the area of 1 byte, and that is minimum from the double. So here all the process is going to be classified on the basis of its type and size. Okay, so let's move on. CAD. Our first topic, that is CAD. This is the data type. So a variable declared as a char type allocate one byte memory space and it can store a single character at a time. So we have heard about these things. This is a data type in C language. So it can allocate one byte memory space onto the RAM and it can store a single character at a time. This is the main point of char. So look at the example that how we are going to logic, how we are going to just creating space onto the RAM. Let's look at. So here you are seeing that char, which is the data type, ch is any variable name. So it might be ch, a, b, c, or anything which is going to be used by the programmer. So this is what we can say data type, and this is variable name. So if we write this code in C language, then the meaning of this thing is that RAM, this is what we have represented as RAM, that is the space of RAM. In that space, a variable ch is allocating 1 byte of memory space into the RAM. So here we can say that we have allocate 1 byte of memory space into the RAM. This, so we can say that this means that I am just allocating a memory space of 1 byte into the RAM and variable name is ch. So it's clear to you that in RAM we can allocate memory space and we can use it. As here we are seeing that this code represents that data type should be char and variable name is ch. So this variable is of type char. Therefore we can say that ch is an variable which is allocating memory on the space whose size is 1 byte. Whose size is 1 byte because 1 char is 1 byte. Therefore the char is going to store one size. So here we can say this ch is going to store size 1 byte, type equal to char, and this ch can be from this range because this ch is a character. So it can store a single character at a time. So it might be from 65 to 19, as in the previous video we have seen that about the ASCII value and the ASCII properties. So we here conclude that from capital A to small z, capital A to capital Z, small a to small z, and from 48 to 57 means from 0 to 9. So here we can conclude these all the ASCII value. So of course the thing is clear to you, I think. If I clarify you one more point about this thing is that it is nothing. It is just an memory space, we can say. So if we are writing char data type whose variable name is ch, then in C programming language, this means that I am just allocating area on the RAM whose size is 1 byte and type is char. So it can store a single character at a time. So this is how we can just do coding in the C language by understanding the graphics of it, by understanding the conclusion that is needed to understand. So this is how the RAM is going to get your and store all the values of the C language, because here we are using a memory space and that is char. Char is a data type whose size is 1 byte. Therefore, in ch, a memory space is going to allocate onto the RAM whose size is 1 byte and type is char. So, moving on the next data type, that is char. That is char. Okay. So read out about this char property. So if I say that char ch is equal to capital A, so this is the wrong. This is wrong. This is not the way to represent a character. We have learned about the character constraint in the previous video. So in that things we have learned that the character constraint is a notation which is enclosed with a single quotes. So therefore we have to consider these things. So here you are looking at cat, which is the data type ch whose size is 1 byte. Ch is variable name equal to this single quotes that is representing as a character constraint. So here I am using capital N. This is right. This is wrong. So or we can represent it in the form of ASCII. Okay. So here you are seeing that char, which is the data type, ch, which is a variable name, and I am using 65. This means that capital A in ASCII value. This is the ASCII value of capital A. Here you are seeing character from A to Z, whose ASCII value is 6 from 65 to 90, small a to small z, whose ASCII value is from 97 to 122, and from 0 to 99, whose ASCII value is from 48 to 57. So this is specifying how the character data type is going to specify the value of character constant only, and not anything like this. As we have seen here that this is not going to be stored, and this is wrong. What this is right way of representing the character constant of character data types. And we have learned about the characters. So we have these things here from capital A to capital Z, small a to small z, from 0 to 9, whose ASCII value is from 65 to 90, from 97 to 122, and from 48 to 57. So note one thing. That in C language the character must be enclosed within a single quote, because single quote is responsible for drop in ASCII value of char. So this is how we can represent a character. So moving on the point number 3, that is how we can store a character. So here looking at this point, you are seeing here that the data type which is of char data type whose variable name is ch equal to set of character. So it is represented here in this form by single quote semicolon. So if we say that it is nothing like this, it is like this. A variable ch is going to allocate into the RAM memory whose size is 1 byte and type is char. You can see here ch is what? Ch is a variable name which of type? Char type. So we can say that ch in RAM memory, ch is going to build and it allocates some memory in the RAM. And during this process, it allocates some memory, and also its type is going to be char type, and char type size is 1 byte. So it is going to store into the RAM memory, and it is going to take 1 byte of the memory of the RAM. So we can say that another example, char A equal to single quota 1. So this is same as what we have started here. So I am using a variable name whose size is 1 byte because of character data type, and having a character constraints because single quotes represent for the character constraints. So what happened in the RAM memory? So this thing happened that A is going to build here whose size is 1 byte because of character data type, and it is going to store value 1 here in this block. Another example, if I see here that char b equal to n, single quotes n. So here b is going to allocate into the RAM memory whose size is 1 byte because of char data types, and it is going to store value n into the RAM memory. Another we see the example that C, which is a variable name, char is the data type, equal to in, which is enclosed within the single quotes, because it is necessary to store a character constants. Therefore, I have stored it into the within the single quarters, which is enclosed within that. So here C variable name is going to allocate some memory to the RAM whose size is 1 byte and type is char data type, because char data type is going to store the maximum size is 1 byte. It may be changed in different memory, or if we say that different in 32-bit system and 64-bit system. So overall the conclusion is that whatever we are going to do or going to approach for making anything, that is going to build into the RAM, and it allocate an area on the memory for the use of the value that is going to be stored there. Okay, so most important point is that single quotes allow one or two character due to escape sequence character. Okay, and escape sequence character is a special character that is made by two character, what it internally treated as a single character. Here we have seen, here is that what we have seen. We have seen it can store a single character only. Then why we are storing IN or AB there? Because of the escape sequence. Because an escape sequence character is a special character. This is a special character. It made by two characters, what it internally treated as a single character, and this is very important. For example, if we say that IN, so this is represented as 13 ASCII value. So this is how we can approach this. So moving on the next data type, that is integer data type. So this is also very important. As we have studied about the character data type, that is char data type. So it can store the size of 1 byte, okay, and it is going to allocate memory into the RAM. That is a fact. So same here we learn about the integer data type. That is int data type, we can say. A variable declared as the int type allocate 2 byte memory space, and it can store a round integer value. Okay. So if we compare with the char, then char can allocate memory of one size. Okay, and it can that the char can store maximum character of one character, we can say. But due to the escape sequence, we can include one more character. But internally, it is behave as a character only. So in integer int data type, we are going to learn that same of the functionality that is predefined in the char, as we have discussed in the char. All the property is going to be same. What? Two things is going to be changed. Its type and its size only. So here we will study that a variable declared as int type allocate 2 byte memory space because size has changed now. Okay, and it can store a round integer value. Okay, so this is two most important point. So int type variable allows 0 to 9 digit and hyphen only. So this is the most important thing. So let's look at some of the examples that we have discussed here. You are seeing here int data type and the variable a, who is going to store some value 10, which is of round integer value, and int type variable allow from 0 to 9 digit and hyphen. Hyphen is allowed for this. So here we can say this is right of representing a variable of int type and whose value is going to be raised from 0 to 9 digits and hyphen. So we can say that a RAM is going to allocate memory of int type and whose size is 2 byte. So A is that variable name which is going to allocate memory to the RAM of size 1 plus 1, that is 2 byte, because int data type has the size 2 byte as we have studied. So int is going to be built there into the RAM and it allocates the memory of size 2 byte. Another example, if we conclude, then A is that variable of type integer whose size is 2 byte. So it will also allocate memory into that space and it will contain 48.7, which is also a right value. Another example, if we say int a equal to minus 25. So a is that variable which is going to store the type int data type and whose size is 2 byte into the RAM memory. Here you can see, and it will store the value minus 25 in it. So this is also the right way of representing the integer character. But here you are seeing that this is the RAM, okay, RAM memory we can say, and this is a variable a who is containing of size 2 byte and type round integer, or we can say integer. So this is the area allocated into the RAM and only store the round integer. It is not going to store any character. It can only store a number, or we can say round integer. So here, for example, number 4, integer a equal to plus 25. So here we are allocating memory into the RAM of integer type whose size is 2 byte, but it is not going to be allocated into the memory. Why? Because of this plus sign. Because we have studied here that int type, that is int data type variable, allows 0 to 9 digits and hyphen and not any plus or anything like any character. So it is not going to be built into the RAM because of this plus sign. What it is going to be built there into the RAM. So this is how we have deal about the integer data type. Now we will move into the float data types. So moving on the float data type, so let's move on. So we can say that a variable declares a float type allocate 4 byte, because we have studied here 4 byte memory space and it can store a fractional value, and the float type variables allow 0 to 9 digit hyphen and period. Period is that decimal point. So moving on to the example, this is same as what we have studied into the integer, char, and we are going to learn about the float data types. So that variable that is declared as the float type allocate 4 byte memory space into the RAM. So 4 byte memory is going to be allocated, and it also store a fractional value and float types variable allowed from 0 to 9 hyphen and period, that is dot. So the value it is going to be stored is from 0 to 9 digits hyphen and period. So if we see here, moving on the example, that I am using the variable whose name is fnum of type float data type. So its size is going to be 4 byte and it can store a fractional value and the float type variables which is allowed from 0 to 9 digits and also hyphen and dot digits. So If we say that this is right or wrong statement, then we will conclude this is a right statement, because f-num is a variable who's containing the float data type. Okay, and float data type can be ranged from 0 to 9 digits. Hyphen can be included in this and dot can be included in this. And here we are seeing that 48.7. So everything is right here. Therefore it is right. Another example, if we look at the f now, then float. Float is a data type of f now. So and equal to hyphen 48.48.7. So this is also a right statement. Okay. Moving on the next example, that is f now. Again I am using the variable name f now, whose data type is float. So it is going to allocate into the RAM memory of size 4 byte, and it is storing the value which is 10. So its range is from 0 to 9. Okay, therefore we can say this is also right. So what happens when we are going to write this into the C language? So fnum is going to allocate some memory into the RAM whose size is 4 byte and type is fractional integer, that is float value. Okay, moving on to the fourth example, that is fnum. Fnum is a variable whose type is float data type, and float data type can store 4 byte of size, and here we are seeing that it can store the value that is not present here. So we can say that this is the wrong one. This is not the way to represent float value in C language. So moving on the next data type, that is double data type. So a variable declared as the double type allocate 8 byte memory space, and it can also store a fractional value, and double type variable allowed from 0 to 9 digit hyphen and a period. So double type is same as that we can say float data types. What its size is different. Its size is larger. Its size is twice than the, we can say that float data types. Its size is 8 byte into the memory. So what happens here is that, let's look at, this is the variable name whose type is double. So double can store a maximum of 8 byte into the memory space, and this is also the right things of storing the value, because it is containing from our range 0 to 9 digits and a hyphen and a periods. Therefore we can say that this is the right things. 48.7, the dot is presented, and 48.7 which is from 0 to 9. Therefore this statement is true. So this is going to allocate memory into the RAM of size 8 byte and type double. Okay. Moving on the next example, that is fnum again, which is a variable name, and double means its size is going to be 8 byte, and also it can store the value whose range is from 0 to 9 digits and might be have hyphen or period in it. Okay. So here you are seeing that hyphen is presented here. 48 point which is a period 7 is present here. So this is also right. Okay. So moving on the another example, that is fnum, a variable data type whose data type is double, and it is going to store the maximum byte 8 byte, because double size is 8 byte, and because of the value from 0 to 9, this value is from 0 to 9 is that range that it can be the value from 0 to 9 means it can be 0 or 9, means any decimal value is weight from 0 to 9. So 10 is also included in it. Therefore, this double data type fnum is going to build into the RAM memory, and here you are seeing that RAM, which is we can say the memory, random access memory, is allocating the variable fnum into the RAM memory whose size is required and type is fractional integer, or we can say double. Okay. Next, moving into the example, another example, that is we are creating the f num again, whose variable we can say this is the variable and type is double. What here in this problem arises that because it not follow this condition that its value is to be allowed from 0 to 9 digits, okay, and hyphen and period and not anything like that we have seen here, that is plus. Because of this reason, this is not going to allocate memory to the RAM, and this is what double says us. So moving into the next thing, that is we have studied today, we will learn about the more thing into the C language about, and we will discuss everything. So thanks for watching. Dhanyavad.